Here what we're going to look at is a topic of reverse percentages. Now reverse percentages are all embedded within a single question that opens up the scale for the entire topic. And that question is fairly straightforward and simple. It's the question of, what did I start with? Now the scenarios around reverse percentages can involve one of two ways. Firstly, typically, if my investment is now worth X after a set number of years, how much did I originally invest? So I've invested this amount of money, after 3 years it's worth this, what did I originally invest? Or I could look at it the opposite direction. An example would be, if this item costs Y in a sale, how much did it originally cost before the sale happened? Now we have to figure out a way to approach this question in order to be able to reverse process calculating a percentage. Now, one thing I want you to remember is there's a trap a lot of people fall into, and I don't want us to fall into that trap ourselves. Now, the trap can be set out using the following question, which I'll actually look at solving in just a moment properly. However, the question would be, the cost of something is £49.50 after a 10% increase. Now let's imagine that we want to find the original amount. So cost being £49.50 after a 10% increase, our logic would say, right, well, we've increased by 10%, so if I do £49.50 and I divide it by 10, what I'll end up getting is £4.95. There's 10%. What I'm then going to do is I'm going to take the £49.50 and I'm going to subtract the £4.95 from that. If I do that, I'll end up getting £44.55. So that's what logic would tell us to do. Our brain would sometimes automatically go to doing that, saying, right, well, I've increased it by 10%, so I'm going to decrease it by 10%. However, this is wrong. The reason it's wrong is if we look at the question, this £49.50 is after the 10% increase. So we take the original amount, we find 10% of it, then we add it on, rather than finding 10% of this new amount and taking it off, because that 10% is different from the 10% we originally took to increase the amount by. So actually following this manner, again, the logic that sometimes our brain would go to is incorrect because it's the wrong 10% we figured out. So we have to approach it a different way, and we actually ask ourselves a different question. And we're looking for a key piece of information. That key piece of information is, what percentage is it now worth? That will allow us to answer it. Because if I know what percentage it's now worth, I can scale this down and then back up to the original amount, and then I can figure it out. So if I look at the first question here, imagine the cost of something is £72 after a 10% decrease. I want to figure this out and figure out what the original amount is. So to do this, what I do is ask myself what I mentioned earlier on, what percentage is it worth now? Well, it's a 10% decrease. If I take 10% off the original, which is 100%, I know I have got 90%. And I know that that 90% is equal to the £72 I have in this scenario. So what I'm going to do is I'm going to try and scale it. And in order to do that, the easiest way to do it would be to figure out what 1% then is, and then go back and figure out the original 100% of the amount. Now, I'm going to scale to 1%. I'm going to imagine this is calculated questions. Sometimes it will appear in a non-calculated paper, and in order to do that, you scale to an amount that's suitable for the scenario. So if this was a non-calculated question, I might scale, rather than to 1%, to 10%, and then multiply it from there. That scaling is important because you've got to make it relevant to the calculations and resources at hand. However, if I was going to scale 90% to 1%, what I'd do is I'd divide by 90 and then go from 1% to 100%, I'd times it by 100. Now this sort of calculation I want you to think of in line with solving an equation for algebra. What we do to one side, we do to the other. So to know what 1% would be, I'm going to take the £72 and I'm going to divide it by 90. And if I do that, what I get is 0.8. I'm then going to take that 0.8 and I'm going to times it by 100 to get the original amount. And what I'll end up getting is £80. So in this case, my original amount for this scenario would be £80. Looking at the second question, similar sort of idea. It's £93.50 and it's after a 15% decrease. So what I have to do is exactly what I just described. What percent do I have now? That's the key piece of information that we've talked about at the top. Scale it down, then scale it up. So in this case, it's a 15% decrease. I know that's 85%, and that's equal to the amount I now have, which is £93.50. Again, I'm going to use my scaling, so I'm going to scale it down to 1%, and then I'm going to scale that to 100%, back to my original amount. And in order to do that, I'm going to divide the 85% by 85. Funnily enough, divide something by itself, you get 1%. And then I'm going to take that 1%, and I'm going to multiply it by 100 to scale it up. Right hand side, I've got to match those calculations. Again, think of it in a similar manner as algebra. What you do to one side, you do to the other. So I'm going to take the 93.50 and divide it by 85 first. If I do that, I get 1.1, and then times it by 100, and what I'll end up getting is £110. So for this one here, the original amount I had was £110. So you'll notice for each of these, I decreased it to get the amount in the question, so I've increased it and got an amount that's bigger than what I started with in the question in the scenario. Now it's a similar sort of idea, but this time the amounts have been increased. So this one here, the £49.50 after 10% increase, this shouts back to what we discussed earlier on. First we figure out what percentage we now have. Well, in this case, it's a 10% increase, so I now have 110%. And I know that that's the £49.50 we have here. So now my scaling comes into play. I'm going to scale it down to 1%, and then I'm going to scale up to the original of 100%. So to do that, we're going to divide by 110 and then times it by 100. Now remember, what I said before is that we've scaled it to 1% here, imagining it's a calculator paper. If this is non-calculator, scale it as appropriate. I could have divided by 11 to get 10% rather than 1% and worked with that. Make sure it's appropriate to what numbers you've got. So what I then need to do is treat it again like algebra, as I mentioned. I'm going to do the exact same here, so I'm going to divide by 110, and then I'm going to multiply it by 100 to get to my original. So if I divide it by 110, I get 0.45, and I'm then going to times that by 100, and I'll get £45. So there you go, the original in this case is £45. Similarly, second one here, the cost is £74.75 after a 15% increase. What was the original? Well, in this case, when we find the percentage we currently have, I've increased by 15%, so I now have 115%. And I know that that's going to equal this £74.75. I can now work with that in a similar fashion. Scale it down, and in this case, I'm going to go and find out what 1% is, scale it up, then to get the original. Scaling it down, we're going to divide by 115, scaling it up, times it by 100. Then, same idea, treat it like algebra, do the same to the other side. So I'm going to start by dividing this one here by 115. I'm going to finish by timesing it by 100. So the £74.75 divided by 115 gives me 0.65. If I then times that by 100, I'll end up getting £65. So my original amount in this case was £65. So there we go. That's how we increase it and decrease it back the way here. So a couple of questions for you. These are both scenario based, so I'm going to give you a moment to do them. Pause the video and have a crack, then I'll work the solutions for you here. So the first one, I've put £252 in a bank account. It's earning 5% interest on what I'd originally put in. How much money did I originally have in my bank account? So again, we need to figure out what percentage I currently have. Well, the percentage I currently have is an increase of 5%, so I've now got 105%, and I know that that's equal to the 252. Then comes our scaling. So in this case, I'm going to scale again to 1%, and then up to 100%, and I'm going to do that by dividing by the percentage, so divide by 105, then times it by 100. So I'm doing that to one side, and what I'm going to do, again, just like algebra, match it on this side. What you do to one side, you do to the other, similar sort of fashion. Divide by 105, times it by 100. Now if I divide by 105, I'll end up getting 2.4, and if I times it by 100, I'll get 240. So what that then means is my original investment was £240. Second one, a car's value has dropped by 11.5% and is now worth £3,053.25. What was it worth when it was new? Now again, similar scenario. The only difference is I've got to figure out the amount of the percentage I've now got, and in this case it's a drop, so it's going to be less than 100%. It's gone down by 11.5%, so I now know that I've got 88.5% left, and that is going to be equal to this £3,053.25. Then comes the same standard set of steps. I want to get the original of 100%, so I'm going to scale to 1% in order to do it. Scaling to 1%, in this case, I'm going to divide by 88.5. Then I'm going to times my answer by 100. So I'm going to do that to the right hand side as well. So I'm going to divide by 88.5, and I'm going to times it by 100. So if I do that amount divided by 88.5, I'm going to get 34.5. I'm then going to times it by 100, and I get 3,450. So the original amount for the car was £3,450. Standard set of steps every time. What percentage do I now have? And then the scaling comes into play. Remember, calculator, I'd always go to 1%. Non-calculator, go to the appropriate percentage that works best for you and the numbers that you've got. So what are the rules when it comes to working with this sort of thing here? The first rule is we have to calculate the percentage the amount is now worth. We ask ourselves, has it been reduced or has it been increased? Remember, a reduction means our percentage is going to be less than 100. An increase, our percentage is now worth more than 100. What we then do is we divide down to find out what 1% is worth. Now that's if it's calculator. We also state or another suitable percentage, for example 10%, if it's non-calculator or if we're able to do that calculation easy. We then multiply up to find the original value. We always multiply up to get 100% at that point. That's what our original value is. We then contextualize our answer. So all what we did before was all about money, so original values, how much you invested, etc. You might get something about weight. You might get something to do with height, etc. You contextualize whatever your answer is based on the scenario. Following these rules, fairly quick, fairly easy. We just have to remember those things to do. Remember, think smart, solve fast.